Hey, good morning. Good morning, guys. So I'm going to make this video for lesson 7. I know we did talk about it last week, but I don't feel like our conversation was productive in any way about lesson 7 in all groups. So I wanted to make a video just so you kind of have the information again. So if you haven't got your stuff out yet, please get out your workbook. Flip to page 25. That's where lesson 7 starts. And you can pause the video now if you need to do that. So this is all about ordering integers and other rational numbers. And and I didn't see many of you, so most of you didn't hear that we have been defining rational numbers incorrectly. So I want to clarify right now, a ration, R-A-T-I-O, a rational number is literally any number you could possibly think of. Rational numbers include integers, include decimals, include fractions, include zero. So a rational number, any number, integers, fractions, decimals, zero, positive, and negative. Rational numbers, integers, fractions, decimals, zero, positive numbers, negative numbers. And really, it kind of defines it right in the name rational. Rational means anything that makes sense. So a rational number is literally any number you can think of. So last week we said it did not include whole numbers, and that's not true. It does. A rational number is any number. Integer is specific. An integer, however, is just a whole number. Rational number, any number. Okay. So hopefully that clears some things up if you worked your way through lesson 7. Okay, so we're going to jump right to example 1. And example 1, again, whenever you're doing these, use a number line. If you're just dealing with negatives, like example 1 is at the bottom of the page, just do the negative side of the number line. Figure out how you're going to scale your number line. Well, this one goes down to negative 20, so I want to end there. But it also uses negative 19. An integer that's one digit away. So the best scale, the scale that makes the most sense, is probably scaling by ones. And you don't have to add every point in, because clearly 19 and 20 are right next to each other. So I did something like that on mine. Just kind of made that halfway point and gave a couple other integers on there. So it says the record temperatures for a town in Maine are negative 20 for January and negative 19 for February. Order the numbers from least to greatest. Explain how you arrived at your answer. Well, clearly from our number line, we can tell that 20 is the least because it is the furthest into the negative. A larger negative number is always smaller in reality. So when we order these from least to greatest, it should look like this: negative 20, comma, negative 19. When we order them from least to greatest, just looks like that: negative 20, comma, negative 19. Let's go on to exercises 2 through 4. And I'm not going to go through all these with you, but let's just get a couple so you get the feel for it. Okay, so it says, for each problem, order the rational numbers from least to greatest by first reading the problem, then drawing a number line and explaining your answer. So a couple things you need to do: order from least to greatest, draw a number line, and explain your answer. John's time for running the mile in class is 9.2 minutes. Jackie's time is 9.18 minutes. Who ran the mile in less time? Okay, so I want to order this from least to greatest. Hi, they're just dropping off my stack. I'm not really talking to myself. I'm making a video for my class. In case you were wondering, it's Heidi's, or it's Wyatt's sister. She's here to drop off my stack. Bye, Heidi. Oh my gosh, sorry guys. So the numbers that we're dealing with are 9.2 and 9.18. Okay, So if we're not sure which one's greater, let's just think about where these might fall on a number line. So I'm going to create my number line with only two integers, 9 and 10. Good morning. 9 and 10. And I want you to do the same thing. Okay, you did that? Great. So let's think about how we could scale between 9 and 10. Well, take a look at the decimal side of your numbers, 9.2 and 9.18. Thank you. So I might want to scale my, what is this called? My line by tenths. So I might say, I might make 10 marks or 9 marks, 9.1, 9.2, 9.3, 9.4, etc. So I can show kind of where some other fractions fall on that number line. And I'm looking for, to figure out which one's greater, 9.2 or 9.18. Well, clearly I can find 9.2 and mark it with a dot right on the number line. Where would 9.18 fall? It's got more digits than 9.2, but is it greater or less than?
Greater.
It's not. It's actually less than. It's less than. Think about that 9.2 as 9.20. Make them have the same number of digits, and you can clearly tell that 9.20 is larger than 9.18. And 9.18 falls right here. Oops. It's hard to see, but oh my gosh, you guys are killing it. So from least to greatest, 9.18, comma 9.2. The last thing that you need to do is write an explanation. Explain why 9.18 is less than 9.2. Well, 9.18 is closer to 0 on a number line. So just something like that, a simple explanation that explains why 9.18 is smaller than 9.2. So you're basically going to do this number line ordering from least to greatest and explanation for exercises 2 through 6, and then continue on the problem set for lesson 7. Have a good day.